Afternoon, everyone. Thanks for your patience. I was asked as a favor, as a convener of this panel, to put the slides together for our first speaker, and I forgot to do so. So if you're ever organizing a panel, that's something you might want to avoid doing. But we now, I think, are all set to go, and it's a pleasure to see so many of you here and to welcome you to Environmental Perspectives on Nature's Nation. I hope you've had the chance, and if you don't, that you will, once we're finished, to have a look at the exhibition that is the sort of the motivating factor for this panel. I don't know if any of you had the chance to be here a couple of years ago when actually David was part of a panel that I was on, which looked at one of the works in our collection, which is also in Nature's Nation as well, along similar lines, as we have a great painting by Albert Bierstadt of Mount Adams in Washington, and we looked at that one work from a variety of perspectives, particularly scientific ones, and it was a really a great event, I think, and that sort of inspired us to do what we'll do today, which is similar but a little bit different in that each of the four scholars here will be speaking not about one work of art, but about different works of art within the exhibition, which they find of interest from a perspective that would be different from my own as an art historian, but that I think will be very compelling for us all to hear about. So we have David Wilcove, who is an ecologist, Amilcare Porporato, who is a civil and environmental engineer, Rob Nixon, who is a professor of English, and George Philander, who is a geoscientist. And I'll tell you a little bit more about each of them before they come up to the podium, but the idea is that they'll speak for 8 or 10 minutes or so, and then if we have time to speak among ourselves a little bit, we'll do that, but we'll also certainly want to hear what you have in the way of questions as well at the end. So I'll begin by introducing David, who is a professor of ecology and evolutionary biology and public affairs. His work focuses on developing innovative ways to protect biodiversity in North America, Southeast Asia, East Asia, and other regions, blending ecology and public policy. He is the author of 2 books and many scientific publications, book chapters, and popular articles dealing with the conservation of biological diversity, endangered species, ornithology, island biogeography, and conservation policy. In 2001, he received the Distinguished Service Award of the Society for Conservation Biology, and in 1990, he was one of 10 scientists awarded a Pew Scholarship in Conservation and the Environment. Prior to joining the Princeton faculty, he was a senior ecologist at the Environmental Defense Fund in Washington, D.C. Please welcome David Wilcove.
Thank you very much, Karl. You will very quickly discern a common theme running through the 4 paintings that I want to show you today. And I want to begin with this one. This is a painting done by Mark Catesby, which appeared in his book, The Natural History of Carolina, Florida, and the Bahama Islands, which was first published in 1731. Now, this book was the first natural history guide to the New World, and this painting is the first authoritative description of the Carolina parakeet, which was the only parrot native to the continental United States. We typically think of parrots as tropical creatures, but in fact, there was once a parrot, this one, that occurred from Florida to North Carolina and occasionally strayed as far north as Virginia, Pennsylvania, New Jersey, and New York. They were noisy, colorful, conspicuous, and gregarious. They liked fruit and grain, which did not endear them to the farmers. Now, Catesby's drawing is immediately recognizable as a Carolina parakeet, and it's rather charming, but it's also rather stilted and lifeless. His account of the species in his book is sparse, although it does include this rather curious comment: Their guts is certain and speedy poison to cats. And one does not know whether he harbored animosity to either parakeets or cats in writing that. So keep this painting in mind, and let me move on to a second rendition of the Carolina parakeet, this one drawn by John James Audubon, and it appeared in his monumental book, The Birds of America, which was published between 1827 and 1838. It's an extraordinary painting. You can see Audubon really captures the behavior and personality of the birds. They've just flown into a cocklebur shrub, and they're about to begin feasting on the sticky seeds. The painting is vibrant, lifelike, and biologically accurate. And I think it is perhaps the finest of the hundreds of paintings that Audubon did for the Birds of America. You can see that Audubon was simply orders of magnitude more skilled as an artist than Catesby from a century ago was. In fact, Audubon was far better as an artist than any of his natural history contemporaries, and he still ranks as one of the greatest ornithological illustrators of all time. Now, his account of the Carolina parakeet includes this rather somber statement: "Our parakeets are very rapidly diminishing in number, and in some districts where 25 years ago they were plentiful, scarcely any are now to be seen." By the beginning of the 20th century, Carolina parakeets were extremely rare, and the last confirmed record we have is of a single bird that was kept at the Cincinnati Zoo and that died in 1918, although there were a few unconfirmed sightings in the southern swamps for another decade or two. But as we get towards the middle of the 20th century, the Carolina parakeet is incontrovertibly gone and gone forever, which raises the question, what caused the Carolina parakeet's extinction? Certainly persecution by angry farmers played a part. So too did the logging of the primeval forests of the East, which were the primary habitat for the birds. And there may have been other problems, such as diseases transmitted accidentally to the parakeets by poultry, but now we're in the realm of speculation. What we can say is that the demise of the parakeet was part of a great and ghastly loss of wildlife that occurred throughout eastern North America at the last quarter of the 19th century and into the beginning of the 20th century. This is an era that saw the extinction of the passenger pigeon, the near extinction of the great bison herds, the disappearance of even animals that we know today to be common, like the white-tailed deer, along with tremendous reductions in populations of shorebirds, waterfowl, and herons, as they were relentlessly hunted for their flesh or their feathers. And this same period of overexploitation was coupled with the felling of most of the remaining old-growth forests in the East. It was this rampant exploitation that ultimately led to the birth of the contemporary conservation movement, which we see reflected in the creation of our national forests in the late 1890s, the creation of the National Wildlife Refuges in the early part of the 20th century by Teddy Roosevelt, the formation of the Audubon Society and other conservation groups, and the passage of laws like the Migratory Bird Treaty Act that ultimately put the brakes on the wholesale commercial slaughter of wildlife and began the process of protecting the habitat of much of our wildlife. Well, I want to jump ahead to a third painting of the Carolina parakeet, and this one is entitled Dying Words. It was created by Walton Ford in 2005. And you can see that it pictures a mortally wounded parakeet, blood, and it's seemingly being comforted by its flock mates. Now, Walton Ford's painting is actually based on this painting, The Death of General Wolfe. which was done by Benjamin West in 1770, and it depicts in a rather grandiose way the death of the British general James Wolfe at the Battle of Quebec in 1759. Perhaps Benjamin West was in some ways equating the loss of the parakeet to an event that we all recognize as having historical importance. And certainly for me, the extinction of the Carolina parakeet is an event of historical importance. And frankly, I am far more saddened by the extinction of the parakeet than I am by General Wolfe's death, although I will add that I don't know either General Wolfe or the Carolina parakeet personally. But interesting enough, in this depiction of parakeets comforting their stricken flock mate, Walton Ford is actually touching upon a rather important factor in the extinction of this species. Because with Carolina parakeets, when one member of the flock was shot, the other members did not flee. Rather, they would gather around the fallen bird and give alarm calls, which allowed for more and more of them to be shot. So John James Audubon was well aware of this. In fact, he wrote, and I'm quoting from the Birds of America, "The parakeets are destroyed in great numbers, for whilst busily engaged in plucking off the fruits or tearing the grain from the stacks, the husbandman approaches them with perfect ease and commits great slaughter among them. All the survivors rise, shriek, fly around for a few moments, and again alight on the very place of imminent danger. The gun is kept at work, 8 or 10 or even 20 are killed at every discharge. The living birds, as if conscious of the death of their companions, sweep over their bodies, screaming as loud as ever, but still return." And reading this passage from Audubon only makes me miss the Carolina parakeet even more. Thank you.
Thank you, David. I don't know what it is about birds, but there are a lot of them in the exhibition, as you may have noted. In fact, yesterday evening, perhaps a few of you were at an event we had with the artist Alexis Rockman, who is a contemporary painter whose representation entitled Aviary is a large, can't miss it, painting hanging in the next to the last gallery of the exhibition, which is full of sort of fantastical birds that sort of ecological disaster may have us looking at someday. A lot of strange hybrid species, and there's something, it would seem, I think there's some birds in Rob's upcoming presentation about that particular animal that engenders a lot of interest and concern, I think, on the part of people who care about the environment. I'm not sure that there are birds in Amilcare's presentation, but he's up next. And he is the Thomas J. Wu 94 Professor of Civil and Environmental Engineering with the department of that name here at Princeton, as well as the Princeton Environmental Institute. And I should actually note that at least 3 of the 4 speakers today, perhaps all 4, are not only affiliated with PEI, the Environmental Institute, but are core faculty within it. And they are our co-sponsor here today in this event, as well as a couple of other ones, one of which you may also be particularly interested in. And I'll just note that the lecture by Naomi Klein, which was snowed out a couple of weeks ago, has, as of this afternoon, been rescheduled for December 11th in McCosh 50, I believe, and I hope that some of you will be able to come to that event, which should be all the better since we're trying it a second time around this time. So Amilcare was formerly at Duke University, where he was the Addy Professor with the Pratt School of Engineering, Civil and Environmental Engineering, with a secondary appointment at the Nicholas School of the Environment. His research is in hydrology, fluid mechanics, and biogeochemistry. He's the author of a book on ecohydrology and on dryland ecology, has won several awards, including the Parasati International Prize from the Institute Veneto, and was elected a Fellow of the American Geophysical Union, from which he received the Hydrology Award from that same organization. He's long been interested in the interplay between art and science, and in 2016 co-developed Beauty in Balance and Balance in Beauty, Bass Connections project at Duke University to explore connections between the laws of physics and abstract modern art, which sounds quite fascinating. But I think today he's here to talk to us a little bit about some of the Dust Bowl imagery in the exhibition. Please welcome Amilcare Porporato.
Thank you, Karl. Hello, everyone. I'm going to talk about how my research on water on landscape connects to the painting Crucified Land by Alexander Haug, which is just behind here, I think. And especially on patterns and how he was fascinated by that. And this here is a landscape, and when water flows on landscape, it creates beautiful patterns. You'll agree with me that this is fascinating, even from a visual point of view. Blue are valleys with these dendritic patterns, and brown is ridges and elevated areas. We are in South Carolina here. I'll show you later where. But this is probably what also fascinated, at least in part, Alexander Haug when he did this Crucified Land. He was fascinated by these regular patterns of planting that gave rise, almost each of them, to a channel of erosion that then propagates into irregular patterns of these valleys and ridges, as we see. And then we have this beautiful stream taking away both water and sediments. I'll come back to my previous slides, which was in the Piedmont of South Carolina, in the Calhoun National Forest, where we did quite a bit of research in this critical zone observatory funded by NSF. We were studying what is the legacy and what are the mechanisms by which, processes by which this intensive agriculture gave rise to very intense erosion and then land degradation. If you do a statistical analysis of the slopes of this landscape, you can see the blue part where it was intensively cultivated. The statistics of the slope are completely different from where actually you have still a pristine forest, and the landscape is much more smooth, and we call it diffuse for a reason I'll tell you in a moment. This type of disasters was not by any means isolated to the South Carolina area. We are all familiar with the Dust Bowl of the 30s. These are just some very dramatic images from that time. This type of events actually stimulated, of course, lots of art, but also, and one of the quintessential examples is Steinbeck's The Grape of Wrath. I tell my students in ecohydrology, this is the best book of ecohydrology, although it has no equations. And probably that makes it even better for them. But also inspired science, policy, engineering. The Soil Conservation Service was created by Roosevelt during that time because of that. The universal soil loss equation, which is still used now, improved, oops, sorry about that, had its origin exactly at that time from the Soil Conservation Service. But let's go back to Haug's painting. So this is the last of his erosion series. In 1939, he has several of these type of paintings before, and this is probably the more striking one. This is in Denton, Texas. He focuses on these patterns, as I said, both the regular one and the irregular ones. And he is usually described as a realistic painter, but I think more than realism, he was focusing on some part of reality, and one of which is really this type of patterns. If you look at his self-portrait here, you can see that the clouds have stripes. There are stripes on the landscape because of cultivation. His collar has checkers. His pullover is all full of lines that probably you can see from there. The wood here, he made a point in making each single vein visible. He was really impressed by this type of patterns. And we are too in our science. So if you, instead of wanting to represent them graphically, you want to do them mathematically, this is what we do. And this is work done with one of my PhD students, Sara Bonetti. And let me just give you a quick example of what you would do to represent it mathematically. So you would write a water equation on the landscape where rainfall gets propagated down the hillsides. Q is the stream flow, which then enters in this equation, which is the elevation height, Z. And that changes because of diffusion. I mentioned diffusion before. We're not going to do much math here. And then it's eroded. There is a minus sign, so land is taken away by this stream flow, which interacts non-linearly with this delta Z, which is the slope, okay? And so there is a competition between these two. And normally the competition is healthy and gives rise to beautiful patterns, but when erosion wins, you can actually have land degradation. And what Sara did is to solve this equation numerically. They look simple, but indeed they're not very easy. So you can only solve them numerically. And as you push this number chi, which is a ratio of these two terms, as if you were increasing intensity of rainfall, taking away vegetation and protection that it does on land, you have increasing creation of gullies and valleys and bifurcation and this beautiful hierarchy that forms landscape. If you see them from above, you see actually this cascade. As the erosion intensifies, the branches get to finer and finer scale. And I want to just point out the universality of this behavior in fluids and other environmental fields. For example, this cascade is typical also of turbulent vortices in fluids. This is a heavier fluid falling down on a lighter fluid. And you can see, imagine these small vortices being the smallest branches and the bigger vortices being the bigger valleys, something like that. And Haug, again, going back to our subject, was very careful to notice all of that also when you see the painting, have a look at he painted one by one all these wakes of sediments and little waves of the free surface. And this is another of the series, Drought Survivors. I believe this is actually lost by fire, so you can only see it in a picture like this. But again, he was struck by these regular patterns. You have all seen probably these ripples on dunes at the beach. If not, next time, pay attention. And they're very regular, but sometimes, if you notice here, they're characterized by defects. That's what physicists call them. It's dislocation defects. Because the regular pattern has to accommodate with the boundary conditions. That's what in the equation would happen. And these are very, again, common in nature. This is a beach of Hunting Island in South Carolina. You can see not only for sediments and air, but for water and air and sediments, the same type. You see the dislocation defects. Sometimes these patterns get very regular. And you see similar patterns even in plants. This is a saguaro cactus. You see the regular patterns and you see the dislocation defects. And if you look up in the sky, also the clouds many times organize themselves in these nice stripes, which also have dislocation defects. So it's very capturing. Thank you. Other artists also see that. Miro, this is probably the optimistic version of the same painting 20 years before. But he also has patterns on the land, and he also notices these patterns in the sky. There are lots of patterns around when you deal with water and plants, in meandering rivers, in the vegetation in semi-arid Africa. This is larger scale, this is small scale. This is a lawn in Israel. It can be explained mathematically. I have to rush, but if you want to know more, you can see that equations describe these patterns. And I want to conclude by just saying that this is kind of universal, not only for the way nature works, but also the way artists abstract from patterns to simpler versions. This is Mondrian, going from a tree to something a little bit more ballistic, but still. And artists and scientists do the same. We start from reality and then we make caricatures of it. And we push it, hopefully not that far. But art, of course, can do much more ballistic things that we cannot do in science. Like you have patterns around the keys, you have leaves of Matisse, you have Escher, and stuff like that. So patterns are really crucial for both science and art. Thank you.
That's great. Thanks, Amilcare. I suppose there's a certain irony in the fact that in this event we've convened to promote the exhibition. We're actually blocking people's access to it. So thanks for your indulgence with the sort of people who need to evidently get to the exhibition this afternoon, which is encouraging as its curator, and we want to encourage. Rob Nixon is the next speaker. Rob is the Curry C. and Thomas A. Barron Family Professor in the Humanities and Environment at Princeton. The author of 4 books, most recently Dream Birds, the birds again, The Natural History of a Fantasy, and Slow Violence and the Environmentalism of the Poor, which won numerous awards, including an American Book Award and the Sprout Prize from the International Studies Association for the best book in environmental studies, and might have won many more awards. It's a very compelling and important work that I've assigned a couple times in different classes. He's currently writing a book about environmental martyrs and the fate of the forests. He writes frequently for the New York Times, the New Yorker, Atlantic Monthly, The Guardian, The Nation, London Review of Books, Times Literary Supplement, Chronicle of Higher Education, and others. His work is focused on the relationship between accelerating rates of environmental change and accelerating rates of economic inequality, asking, in what ways do rich and poor suffer unequal exposure to the perils of a climate destabilization? And in what ways do rich and poor enjoy unequal access to resources in a time of heightened climactic stress? Such questions, he believed, demand imaginative, ethical, technological, and political responses. Please welcome Rob Nixon.
Great. Thanks so much, Karl, for putting this together, and thank you all for coming. So I'm really going to talk just about the one image. Do you have a clicker? Yeah. I'm just going to talk about one image today, and I wanted to use that image to reflect on some quite large questions. And one of those questions is what can art do? We can often feel that we're drowning in data, statistics and charts and graphs, which become ever more sophisticated and can do extraordinary work in enhancing and deepening our understanding of environmental concerns. But they can't do the job alone. And so one of the things that draws me to the environmental arts is the power of art to make large-scale effects visceral, to bring them within the domain of felt experience, to make them visceral. And many of the most challenging environmental crises and concerns of our time are extraordinarily large scale. They're very hard to get imaginative traction on. And the artist that I'm going to talk about today, Chris Jordan, is an artist who enjoys working in this space where he's trying to figure out how to make large-scale effects immediate and granular. And when Chris Jordan heard about the Great Pacific Garbage Patch, he was immediately intrigued. Now, many of you have probably heard of this. Great Pacific Garbage Patch, the scale of it is uncertain. Sometimes it's described as twice the size of Texas. Sometimes it's described as the 8th continent. It's this enormous repository of plastics that the currents have brought together in the North Pacific. And so Chris Jordan had the idea of flying over the Great Pacific Garbage Patch and trying to give a visceral account of its appearance. In doing so, he discovered that paradoxically, this Great Pacific Garbage Patch is virtually invisible from the air, largely because many of the plastic particles have disintegrated into microbeads and so forth, and also they've been covered in algae or they've suspended below the surface. So he didn't have an object of artistic focus. So it's very different in this regard from, say, the other great structures like the Great Barrier Reef or the Great Wall of China, which can be seen from space. So he was talking to somebody he met about this quandary, this imaginative quandary, and this person said, what I suggest is you go to Midway Atoll in the North Pacific, one of the most isolated places on Earth, and take a look at what's happening to the albatrosses there. And that is what inspired his Midway Atoll series. There we go. So this is the image that's in Nature's Nation from the Midway Atoll series. So what happens is that Midway Atoll has almost no humans, just scientists, but it has, not to disqualify them, okay, Freudian slip. So Midway Atoll has hundreds of thousands of laysan and black-footed albatrosses breeding. It's the largest breeding concentration of those birds anywhere on Earth. And albatrosses fly enormous distances to collect their food, and they then regurgitate that food to the chicks. And so across the atoll, Chris Jordan kept stumbling upon these dead albatrosses, and in dissecting them, came to this realization that they were being fed plastics from the Great Pacific Garbage Patch. So at the beginning I said, how can we make data visceral? And his photographs for me are all about the viscera, about the gut. What these most fundamental biological acts of procreating and nourishing through parental upchuck, if you like, are connected through these images to the throwaway society. And so the chicks die of dehydration and malnutrition. And so Chris has worked with a plastic specialist at the Smithsonian Museum, and there's both an aesthetic dissection, if you like, and also a scientific dissection, so that he would transfer the contents of each albatross gut into a Ziploc bag and then send them to the Smithsonian. So what did he find? He found pink bottles of nail varnish. He found a plastic fork, which presumably was used to consume a more satisfying meal than the albatross got. He discovered a plastic Buddha, a plastic polar bear that had migrated from its native realm to the tropical Pacific. In one single albatross gut, he discovered 22 bottle caps, one of which was recent enough for him to read on the side, press down and close, which on my darker days sound like planetary instructions. But the subject that his photographic series raises is the status of grief. What do we do with environmental grief? And for many people, grief is seen as a negative emotion. But it doesn't have to be a place of stuckness. I do think that we avoid passing through grief at our peril, and I think this applies to many realms of life. And I wanted to connect this grief, and for me, I should say, where is this? Oh, here we go. For me, I should say there's an echo here of the Archaeopteryx. the beginning of bird life, that great transition from reptiles to birds, in the form of the image. And so one of the things that this photograph asks of me is what kind of future ancestors do we want to become? What will our fingerprint or our signature be in the fossil record? Midway Atoll, as I say, is teeming with albatrosses. And one of the things that Princeton Environmental Institute prides itself on is the collaboration that we have with the Princeton Public Library on one of the great environmental film festivals of the world, which happens every April. And last year, we showed Chris Jordan's film called Albatross. And he came and talked about it, and it was, in fact, the award-winning film of the festival. And he talked very powerfully about his toggling between the sense of grief at the plastic deposits in the guts of these baby albatrosses, and the absolute unavoidable amazement at the plenitude of life on Midway Atoll. The sense of the fecundity, the swarming, baying presence of these albatrosses. And it got me thinking a little bit about different types of extinction. And if we think back to something that David mentioned, which was the Cincinnati Zoo, in the case of the Martha, the last passenger pigeon who died in 1914, in the case of birds that flock together in vast numbers, like a passenger pigeon, you have the biological death with the last of the pigeon, but in a sense, there's an experiential death that predates that, because what is so distinctive about these species is the way they flock in hundreds and thousands and even millions, darkening the skies. The albatross is somewhat different in that most people won't ever see an albatross, and if you do encounter them on the ocean, they're normally solitary. But when you have in aggregate 700,000 albatrosses on a small island, there is something of the magnificent volume and aggregation of life that can't fail to impress you. And I think that that's really what, for me, Chris Jordan's work is doing, is trying to enter into the global consequences, our implication in the throwaway society, to enter into that through the gut of a desiccated baby albatross, but also to pass through that into a larger celebration of the sheer amazing, voluminous character of life itself. My final remark has to do with an image that isn't in the show, which is by sculptor Kelly Jasvac. And it refers to plastiglomerates, which a Canadian geologist in 2012, I think, determined were a new substance on Earth. And that in the Anthropocene age, human impacts are such that we're transforming many of the biogeochemical characteristics of the planet. And one of the new things to emerge from this is plastiglomerates, where you have molten plastic enfolded into other sediments and creating new geological forms that quite probably will outlast us. So if we think back to the post-World War II rise in plastic culture, plastics were seen as uncostly, short-lived, and so I think there's a line of connection between Chris Jordan's albatross images and Kelly Jasvac's plastiglomerates that gets us to rethink the idea that plastics are cheap and that they are ephemeral. Thank you very much.
Thank you, Rob. I hope I won't. So the next time you're asked paper or plastic, you'll know what to say. Our last speaker, George Philander, is I'm particularly interested in his presentation because he's provided me with a bio, which you'll see announces an interesting presentation, I think. He is the Knox Taylor Professor Emeritus of Geosciences, is a climate scientist with special interest in phenomena such as El Nino, La Nina, ice ages, and global warming. Indeed, he coined the term La Nina when he published the book El Nino, La Nina, and the Southern Oscillation. George is a scientist and also an optimist, so that he can be described as an optimistic climate scientist. A rare bird, speaking of birds, I think. This may sound like an oxymoron, especially if you pay attention to recent news about global warming issues, but he assures me that this is not the case. In his presentation, he intends to convince us that we should be all optimistic environmentalists. George Philander.
Professor Kusserow. I am indeed determined to persuade you that there's far too much pessimism in the world and that we should be optimistic about it. I want to propose that there's far too much pessimism and that we ought to be optimistic about planet Earth. Let me remind you that a few days ago, on the 11th day of the 11th month, several world leaders met in Paris to commemorate the end of World War I. And it's been said of that colossal disaster, a few million people lost their lives. I think it's Clemenceau said, concluded that war is too important to be left to generals. And what I want to persuade you of in the next few minutes is that planet Earth is too important to be left to scientists. And I'm not being frivolous, but the problem we face, namely global warming, requires the involvement of everyone, not merely of scientists, because the problem we face is beyond the scope of science. Science has serious limitations because it's mute on ethical issues. As Galileo pointed out to the Pope, science can tell us how the heavens go, but not how to go to heaven. Science tells us how things work, but not how to live our lives. Global warming is a major challenge because it involves both science and ethics. What is the right balance between our obligations to future generations and our responsibilities to those living in abject poverty? The current strategy for finding an answer to this very difficult question is to scare people. We sound alerts of imminent gloom and doom and offer advice on how to adapt and to mitigate disasters. That strategy is inadequate. It's causing global warming to be polarizing, and it leads to confrontation. The challenge is to bridge the profoundly different worlds of human affairs and of science. In human affairs, compromise is a requisite, compassion is a virtue. Science, on the other hand, is uncompromising. If you say that 2 + 2 is 6 and I say it's 8, we don't settle on 7 as the right answer. The scientific questions have answers. It's a rational activity, produces objective results, and the results are independent of religion, ethnicity, gender, age. Those subjective factors are of crucial importance in the world of human affairs. I propose that we bridge the gulf between the worlds of science and of human affairs by appealing to everyone's love for this very, very special planet on which we live. This is the only planet in the entire universe that is known to be habitable. Now, you can only love that which you know, and unfortunately, few people know why our planet is habitable. To correct that state of affairs, I want you to have a careful look at this picture of Bierstadt, the lovely painting of Mount Adams, and it has both a political message and it also provides valuable scientific information. So let's start with the scientific information. If you were an alien and you landed on that meadow, you were in search of a habitable planet, what will impress you the most are the animals, the horses and the humans. And it's simply because they move in interesting ways. The clouds also move, but clouds are not nearly as interesting as animals. And so the question is, how do the animals stay alive? How do you stay alive? You breathe. And by doing so, you inhale oxygen and you exhale something else. You exhale carbon dioxide. If we were to shut this room entirely, allow no fresh air to enter, no air to leave, we'll soon find ourselves in dire straits. We'll suffocate. And what we will need is a contraption that does the reverse of what we do. We'll need a contraption that inhales carbon dioxide and exhales oxygen. And such a contraption is, of course, a plant. So we have to pay special attention to Bierstadt's trees and the meadow in front. They seem to be flourishing. And to do their thing, it's called photosynthesis, the trees need two things. They need sunlight. And in that painting, the sunlight is spectacular up on the mountain peak. The other thing that the plants will need is water. And in the painting, you see water in two forms. You see it as snow on the mountain peak, and you see it as a cloud, beautiful cloud. So we'll come back to that. Scientists from that can make all sorts of inferences about the temperature of this place. And we'll also realize that this water can have a third form, namely liquid. And in fact, both the cloud and the snow have their origin in the ocean. And so we have to turn to the ocean, and we have to put the atmosphere in motion. So the atmosphere the winds have to harvest water from the oceans, and then they deposit those into clouds. The clouds disperse across the planet, and they move strictly in accord with the laws of physics. And in doing so, they bring water to some regions, and they deprive other regions of water. One of the laws of physics will tell you that what goes up must come down. To have rain, the air has to rise, and that rain can give you a jungle, but what goes up must come down, and so where the air comes down, you do not have rain, and you have deserts. And so you can infer from this picture of Bierstadt that in addition to jungles, we must have deserts. And scientists can provide us with this spectacular picture, which shows the great diversity of climatic zones on the planet. And what you can clearly see the Sahara Desert, you can see the jungles of the Amazon basin and so forth. In between you have tundras and you have savannas and so forth. What is surprising about this picture is that the oceans also have climatic zones. And the oceans also have jungles and deserts. The purple regions are the deserts. The green regions are the jungles. And so for example, much of the carbon dioxide being taken out of the atmosphere happens around Antarctica. The light green is basically a jungle. Now, the ocean provides about half the oxygen in the atmosphere, so that every breath you take, every second breath is actually oxygen from the ocean that you inhabit. What we must next pay attention to is that because of this constant recycling, each of you has about 70% of your body weight as water. That water has been in the ocean. So you're part of a reservoir that constantly recycles with other reservoirs, with the ocean, with the atmosphere, with the clouds, water. This recycling, it's the reason why the planet is habitable. This recycling has strange implications. It means that inside you are some water molecules that have been to the moon, simply because there have been astronauts on the moon. And we've all been, whether you like it or not, we all participate in recycling. In your bones, you have carbon from Joan of Arc, because she was burned to the stake, and her carbon went into the atmosphere. And so once it's in the atmosphere, you participate. It has significant political implications, this recycling. As John Donne would say, no man is an island. We're all interconnected. And it's not possible to take care of planet Earth by yourself or on your own, not for any nation, not for any group. So that it's going to be one of the important messages. Now, this particular picture, spectacular as it is but a snapshot of a continually changing panorama. And if we have time, I'll show a video of how this changes. For example, the source of energy for the recycling, the sunlight changes daily, it changes seasonally, it also changes over thousands of years. A quick summary of that recirculation is this picture, as a graph. Now, suppose, imagine for a moment that is a picture, a graph of a temperature of a patient in a hospital, and suppose you were a nurse looking at this, then you'd be thoroughly alarmed. The patient arrives with a very high fever, gets some medication, and it's successful, the temperature drops, and then at some stage the patient starts having convulsions, and the temperature fluctuates wildly. So at this stage you decide that we need to monitor some more vital signs of the patient, and the picture becomes even more alarming. That what you see here at the top, let's suppose that's heartbeat, and the bottom one is temperature again. There's this sudden spike at the end, and I'm sure you will rush the patient off to the emergency room. Now, in reality, this is actually the temperature of our planet, and the temperature over millions of years, 60 million. And to tell the whole story, implicit in this graph, is an absolutely remarkable story. It's about the drifting of continents, and it's again about their effect on the recycling that keeps the planet habitable. If we go back 200 million years, all the continents in this picture, the continents are quite far apart, but 200 million years ago, they were all clustered around around Africa, basically. And we had a huge continent, Pangaea. Then the family split up. India dashed off to the north, got married to Asia, produced the Himalayas. Australia is also dashing off, is much slower, hasn't reached Asia yet. The Americas drifted westward, and the drifting of continents gave rise to mountains. And mountains play a crucial role in this recycling. If, for example, we have this example of Bierstadt's picture from the Rockies, there are volcanoes, there's a whole chain of volcanoes up and down the Andes, the Rockies, the other side of the Pacific. We have volcanoes too. They erupt regularly, and they change the atmospheric composition. By changing the atmospheric composition, they change the climate. And we see evidence for those climate changes in graphs such as this. So in reality, the climate changes, we've had global cooling since the demise of the dinosaurs. That favored the rise of evolution of all sorts of exotic mammals, giraffes, zebras, hippopotamus, and so forth. In due course, our ancestors, African hominids, arrived about 3 million years ago. And subsequently, we, Homo sapiens, arrived, and we arrived in the midst of the considerable turmoil, recurrent ice ages. So these fluctuations are actually ice ages. And in particular, if you look at this picture, we arrived very recently at the beginning of this picture, Homo sapiens, and we amounted to nothing. Everything we've accomplished, we accomplished in the last few thousand years. That's the very end of this graph. And we progressed with amazing rapidity. We invented agriculture. We multiplied our numbers by enormously. We built cities, civilizations. And a byproduct of those activities is that spike in the red curve. So that spike is the rise of carbon dioxide. And what you can conclude from this is that the present is a very precarious moment in the history of the planet. It's a moment for circumspection, for caution. It's, if nothing else can persuade you that global warming is a problem, then I would submit that these two graphs provide ample evidence for being concerned. So in conclusion, let me say something about what we should do about this. I could summarize what I've just been telling you. That global warming is a very difficult problem. The challenge is to bridge two profoundly different words, and I feel we're adopting the wrong strategy. That, let me just read in conclusion. I feel that we're emphasizing telling people over and over about imminent gloom and doom, about the terrible thing that will happen, that we are overdoing that. I've had some experience in Africa with the education program. The big priority, highest priority in Africa is not global warming, it's education, for the simple reason that poverty is the big problem. And the key to the alleviation of poverty is education. What I discovered there is to get students interested in science, I was much more successful telling them that they're lucky to be where they are, that they're living in this amazing planet, and they should take care of it for that reason. I want to point out that sitting in Africa, foreigners often come, and they have lots of advice. The advice is about how to adapt and mitigate. And from my perspective, Africans suffer from an excess of advice and a paucity of opportunities. So, in conclusion, I want to show you this picture, which was taken in 1969. Next year will be the 50th anniversary of the first picture of planet Earth from the moon. And so I propose that we spend next year and celebrate planet Earth. And I would much appreciate any suggestions from you as to how we should proceed with that. Thank you.
Thank you, George, very much for reminding us of the radical interconnectedness across space and time of this exceptional planet, and for showing us its beauty. That's actually one of the things that we, in a way, wrestled with in putting the exhibition together, in telling a story about environmental change, which the show does. We didn't want it to be an entirely downbeat experience, and the thing that, in a way, I think rescues it from that is the incredible beauty of a lot of the work that's displayed, which is at once encouraging and frightening in a way to think that we're in a place where a lot of that could go away. I'd like to thank the panelists, all four of them, and ask you to please join me in doing so for the really great presentations. It's one of the great privileges for me as a person working at the museum within a university like this is how incredibly rich a place it is, and we had a sense for that, to see the works described from the exhibition in ways that really are illuminating and I think productive in thinking about things differently. And in light of the time, I think it might be a good idea to just go straight to questions. I'm sure some of you have them, and how are we managing the microphones? Okay, so please, if you have a question for the group or for anyone in particular, maybe just say that at the outset, and we'd welcome them. Thanks.
Thank you so much for coming today. I heard the phrase environmental grief. I've never heard that before. Thank you. The phrase environmental grief, I've never heard that before, and it really moved me. I'm wondering what the origin of that phrase is, where it's coming from. It resonates so much today.
Yeah, thanks. Thanks for that question. Just looking at the painting, I was thinking of environmental grief, because one of the things about grief is it's a personal emotion, but it's also a collective experience very often. And we know part of my ancestry is Irish. At an event like an Irish wake, there is grief, but there's also a re-embodiment of the lost person through stories and anecdotes and laughter and tears. And so grief encompasses an enormous spectrum of responses, imaginative, emotional, and scientific. I mean, there is a science of what we're losing. And I think one of the things I like about Chris Jordan's work is that he, rather than sidestepping grief, he walks through it and gets to a place of celebration that is also a place that acknowledges loss and tries to dramatize the costs of what we're losing by emphasizing and allowing us to see in new ways what it is that we love.
Thank you. This question is maybe a little bit further, but given that it appears that machine learning is going to be increasingly prevalent in our society, what do you imagine the effect on the environment will be, both positive and negative?
Maybe as an engineer I should speak. It's a powerful tool, and it's as all powerful tools, it has two sides, right? Has become very fashionable, the name machine learning. I would like us to learn more than the machine. It's going to help us synthesize data that could be useful. It's also, as a tool, just going to produce more data, which sometimes people say garbage in, garbage out, and we saw the effect of garbage on the environment. It's going to happen. It's going to be more and more prevalent, and I think it's still to us the way we use it. It's going to help us a lot. It's being used to extract information more quickly, more in a more meaningful way. And the more science there is under this fashion, the more useful it will be. That's my answer.
Well, thanks. I thought the panel was great, but it is a fairly grim crew. George Philander, I wanted to put this to you because you're the least grim of the crew, and I also appreciate that, but there was something that struck at my heart. It was that red line, Professor Philander, where you've got the accumulation of CO2 in the atmosphere like nothing else before or since. I wonder if you could comment on that. It sort of undercut the hopeful and positive and beautiful message that you otherwise bring.
Yeah, we're going to sound pedantic, but don't mistake correlations for causality. And so we shouldn't assume that just because CO2 is going up that all hell will... There was a high correlation between the temperature and carbon dioxide. But more generally, I want to get back to the previous question also. We do science for two reasons. The one is to satisfy curiosity, and the other one is for practical benefits. And I'm old enough to be a child of Sputnik. During the Cold War, scientists were indulged, and we were encouraged to pursue all sorts of crazy questions. It was a very exciting period. Since the end of the Cold War, politicians want to know, what have you done for me lately? And they want very concrete results. And I feel it's hurting the science. There's a strong focus now on getting machines to help you think. And that I feel there's too little attention being given to simply science out of curiosity. And the astonishing thing about the pictures I showed, what happened over the ice ages, whatever, the last 60 million years, we're amazingly ignorant. We don't have explanations. We don't really know why the ice ages occurred. And I'm amazed the big scientific funding foundations, for example, NOAA, will only let you consider climate over the last 1,000 years. They won't support climate goes further back. NASA is going to celebrate that picture next year, and NASA invited proposals. However, they want proposals only from people looking at the moon itself or looking out further to space. They do not want people to look back at planet Earth.
Thank you very much. At some point, and I was struck by that, we were shown and we've heard a lot about these patterns on water, patterns on the sand, and then on the plants. And also artists recreated the same patterns in their art. And all these patterns were called defects. So my suggestion is to call it rather marvels, since we are supposed to be optimistic. Is there any chance to change that?
I don't think so. So just to clarify, so the patterns are not called defects. The defects is only when the regular pattern gets irregular because they merge. And the word defects comes from crystallography. So when you have crystals, which are perfectly beautiful patterns, and you have an extra atom or something else that dislocates them, these are the defects. So you are absolutely right. There is the beautiful patterns should not be called defects.
I find it very disturbing about the amount of plastic that is floating around in the ocean. Now I see different articles and things about these machines that they set up that can collect some of the debris and get rid of it, but it seems to me much more needs to be done, and I'm just wondering what the scientific community does about it, or do they do anything, or, you know, I'm just kind of curious as to where they stand on it, because I think it's just a terrible thing going on right now. And it's certainly going to make problems for the future in what happens in the ocean and to our whole environment.
I can't speak for the scientific community, but I mean some of the problems have to do with governance. And in terms of single-use plastics, there are societies that have made huge strides, like I think in Ireland, after they imposed the plastic bag tax, usage of plastic bags dropped by something like 95%. And so it was both an economic thing and then it became a cultural stigma, in a sense. And it doesn't have to be a rich nation issue. Rwanda has done something similar. And I know in South Africa they call the plastic bag the national flower because it's impaled on the fences so much. And so there are some practical models. I mean, it's an immense problem, and something like 20% of the debris in the Great Pacific Vortex or garbage patch is now apparently comes from Fukushima, is post-Fukushima, and so there are factors, beyond our control. But certainly, at a level of governance, there are some really good precedents for at least slowing the rate of plastic accumulation.
So I think we have time for one more question. Okay.
Thank you very much. This is my question. You showed a painting of Dust Bowl, and you saw and showed us patterns. And when I looked at that painting for the first time today, I saw a hand and a crucifix. The hand might have been a black hand, or it might have been the desiccated hand of a white farmer. Are we still in the CP Snow world of two cultures? And how do we bridge that? Why do we look at the same picture and see two different things?
I think you can see many things in a painting, and I don't think I'm the one who can respond well to this question. I think there are lots of messages, and my choice was to focus on what was close to my science. That's why I decided to go through this reading, and it would be, I think we could speak for probably hours and hours on different interpretations. Definitely the fact that he wanted to crucify and that he was not just obsessed and interested in patterns, but also because of the Dust Bowl and the environmental disasters. I don't question that. Probably you guys can.
I mean, I think we were asked to bring our disciplinary expertise to bear on the paintings. And so it was just about shifting the angle of vision. And one of the beautiful things about this exhibition is that no two people will come out seeing the same painting the same way, because they are so rich and so suggestive. But I think, at least if I understand Karl's idea correctly, the idea was to ring the changes on perception by bringing disciplinary patterns of thought, if you like, to bear on these images. That's a very, very good question, and it's what I believe PE, Princeton Environmental Institute, and the Art Museum are all about.
Karl, in response to your question, do we have two cultures? I would say we do indeed. And so I want to congratulate Professor Kusserow on an exceptionally good exhibit. And on behalf of all of us, ask you to have a follow-up which tries to bridge the gulf between the arts and the science.
That can be the next. So thank you. David is nudging the plastic to my side of the table. I think trying to implicate me, so that may be a good time. Yeah. I hope that though there is some grim news, and that's a well-taken comment, that we might see these perspectives as those of people who are concerned and committed. I think, all is not lost, but I think it's fair to say that we are losing, and that is something that we should all be very concerned about. And that, I can tell you, is really the main reason that I spent 7 years of my life putting this show together. And I say that not melodramatically, but because I think it needs to be said. And I really thank the panelists here for bringing their perspectives to a project that I've really been very grateful to have had the opportunity to work on. And I thank you all for coming to learn a little bit more about it. So thank you all very much.